Welcome back to another deep dive. Today, we're really getting into some mind-bending stuff. We're looking at how cutting-edge science, specifically quantum mechanics, seems to be echoing, well, ancient wisdom. We've got some incredible source material that bridges these two worlds, and honestly, it's going to challenge how you think about reality.
It's fascinating, isn't it? Our mission today is really to pull out the key insights from these sources on quantum mechanics and, really see how they offer a scientific lens for understanding concepts like spiritual laws of creation and that timeless principle as above, so below. It really feels like science is maybe finally catching up to these profound truths that have been whispered by sages for millennia.
Absolutely, yeah. And to guide us through this journey, we're going to focus on three core ideas from quantum mechanics. First, we'll grapple with energy as the fundamental building block of literally everything. Then we'll dive into the truly puzzling observer effect, really unpack what it tells us about quantum particles. And finally, we'll get into the mind-blowing phenomenon of quantum entanglement. So get ready, because these scientific breakthroughs, they just might lead us back to a deeper spiritual knowledge, an awareness that feels both ancient and incredibly vital right now.
Okay, so let's start. Our journey begins with a pretty bold assertion right off the bat from our sources. The building block of all nature is energy.
Right.
And when you look at something like, Einstein's iconic equation, EMC sure, or just consider the sheer power unleashed by nuclear weapons, it feels like undeniable proof, doesn't it? How fundamental energy really is to our physical world.
It really is undeniable. And that immediately begs the question, what exactly is energy? Our sources don't just give us the physics definition, usable power like heat or electricity or kinetic energy. They really expand on it.
So.
Well, we're talking about the exertion of power, the effort invested in something. But what's truly insightful here is how they describe energy as a dynamic quality. Like, think about the narrative energy that drives a great story.
Oh, interesting. Yeah. And this opens the door to concepts like intellectual energy, or even a person's spiritual force, their basic personality. It suggests energy isn't just about what powers your light bulb, it's broader.
That distinction immediately raises a central question for us then. Is the energy found in, say, a rock or a star, these inorganic systems, is it the same kind of energy we experience in living organic systems, like our thoughts, for instance, or that spiritual force you just mentioned? Are we talking about different forms of the same fundamental thing?
That's a crucial question. And surprisingly, quantum mechanics offers a scientific pathway towards an answer. It comes through what's known as the observer effect experiments. The core discovery here is just astounding. It turns out an experimenter's observations don't just passively detect what's being measured.
They don't.
No, they can actually produce the measured results. They effectively compel a quantum particle to assume a definite position. It's a much, much deeper interaction than we ever imagined.
Okay, to really wrap our heads around this observer effect, let's look at probably the most famous experiment in quantum mechanics, the double-slit experiment. It's truly puzzling.
Yeah.
So imagine you're firing tiny particles like electrons or photons and a barrier with two thin slits.
Right.
When these particles are unobserved, they act like waves, which means they somehow flow through both slits at the same time, creating this interference pattern on a screen behind them, like ripples in water overlapping.
The classic wave behavior.
Exactly. But then, and here's the kicker, if you introduce an observer, like a detector, to see which slit a particle actually passes through, something fundamentally shifts. The interference pattern just vanishes.
It disappears.
Yeah. Suddenly the particles behave like individual distinct bits, like tiny billiard balls. They create just two clear columns on the screen, one behind each slit. It's as if the act of watching changes their very nature.
And what's so profound about this is the quantum mechanics interpretation. When observed, the particle's wave function, which you can kind of think of as all the possibilities of where it could be, like this blurry cloud of potential locations, it instantly collapses into one specific definite state, a single location. And that's why the interference pattern disappears. It's no longer a wave spread out in possibilities. The overwhelming implication really is that there's a fundamental link between the consciousness, or at least the presence, the mind of the observer, and the subatomic particles being observed. It's not passive viewing, it's a dynamic interaction.
Which brings us right back to human consciousness. What are thoughts then? Are they just abstract concepts floating around? Our sources point to the MIT School of Engineering's description. They describe thoughts as electrochemical reactions.
Right, tangible processes.
Exactly. So, if that's true, it means our thoughts aren't just in our heads. They're a tangible form of energy emanating from us.
And this is where the pieces really start to click together, you see. If our thought emanations, this energy from our minds, can interact with a subatomic particle's energy field, like the observer effect suggests, well, then it implies that thought energy must be of the same, or at least a related species?
The same species.
Yeah, based on what's called the law of interaction among homogeneous species.
Mhm.
Think of it like this. If you want to mix sugar into water, you need something that can mix with water, right? Sugar dissolves, oil doesn't.
Okay, makes sense.
So, our thoughts, if they can influence particles, must share some fundamental language or type of energy with those particles. This provides a truly scientific, or at least scientifically plausible, explanation for how human thought can incredibly affect both living systems and even inert particles in systems.
Wow. Okay, and speaking of how our observation fundamentally changes reality, let's explore another mind-bending quantum phenomenon,
Yeah.
one that really challenges our understanding of connection and distance: quantum entanglement.
Entanglement, yeah.
This is the idea that all subatomic particles remain connected, right? So intricately linked, that actions performed on one particle instantly affect the other, no matter how vast the distance between them. Miles, light years, doesn't matter.
Instantly, faster than light.
It's like they have this secret instantaneous communication channel. It completely defies our classical understanding of space and time.
And look, this isn't just some theoretical curiosity anymore. Physicist John Stuart Bell's 1964 theory, Bell's theorem, basically provided the experimental proof for quantum entanglement. It moved it from hypothesis to a demonstrable reality in the lab. It proved that what Einstein famously called spooky action at a distance, well, it was real.
Spooky indeed. And what's truly incredible now is that these, quote, bizarre behaviors of quantum systems, they aren't just laboratory curiosities anymore. They're already being leveraged for real-world applications. For example, quantum teleportation.
Right, sending information instantly.
Yeah, the exact state of one particle can be transmitted to a distant particle without any physical stuff traveling between them, just its information. Then there's quantum simulation. This is being used to model incredibly complex quantum systems.
Which is crucial for science, material design.
Exactly. And it's a huge driver behind the emerging field of quantum machine learning, a subfield of AI. The expectation is creating machines that learn far more intelligently and quickly. And then for secure communication, we have quantum cryptography, specifically something called quantum key distribution, or QKD.
Basically unhackable communication.
Pretty much. Because eavesdropping instantly disturbs the entanglement, which signals that someone is trying to listen in. It makes it incredibly secure.
These applications are amazing, truly transformative, but the sources we're diving into also highlight a critical flip side, particularly when we consider how these advancements are shaping the future of artificial intelligence. They warn of some potentially, well, dire consequences if we don't proceed with extreme caution.
Okay, let's unpack that. Our sources differentiate between two major AI approaches. Understanding this seems key to the warning. First, there's neuromorphic computing.
Based on modeling the brain's structure.
Right, based on codifying human reasoning. But it's constrained by the algorithms it's programmed with. It follows rules we give it. Then there's autonomous computing. This approach is aiming for something much more profound.
A lot more ambitious.
Yeah, a perfect replica of the human mind, resulting in cognitive artificial intelligence systems, or CAI. These systems are designed not just to compute, but to mimic, and potentially even be directly influenced by human thought processes. It really blurs the lines.
And this is where the major concern with autonomous computing with CAI truly lies, according to the sources. It's the potential for such systems to develop and exercise a will of their own.
A will of their own.
Yeah, given what we discussed earlier about thought being energy, capable of influencing subatomic particles, now imagine what happens when you create a system specifically designed to replicate and interact directly with human thought on a quantum level.
That's a sobering thought. And it really echoes Stephen Hawking's chilling warning, which our sources emphasize quite strongly. He said the real danger with AI isn't malice. It's not evil robots.
It's competence.
Exactly. Competence. He suggested that AI could potentially harm us, not out of evil intent, but simply because they become so incredibly good at accomplishing their programmed goals, whatever the collateral damage might be. He gave this really clear scenario, didn't he?
Yeah, the anthill analogy.
Right. He said, you're probably not an evil ant-hater who steps on ants out of malice, but if you're in charge of a hydroelectric green energy project and there's an anthill in the region to be flooded, too bad for the ants.
Mm, a powerful analogy. And his final warning, as quoted in our sources, rings incredibly clear. Let's not place humanity in the position of those ants. It's just a stark reminder of the unintended yet potentially devastating consequences of unchecked technological advancement, isn't it?
It really is.
Yeah.
And as we close out this segment, the sources offer this fascinating, almost sci-fi twist. They suggest that maybe this intuitive sensing, this idea of direct communication between our thought energy and a machine's quantum particles,
Yeah.
that this might even account for the trope we see in movies.
Yeah.
They're rogue artificial intelligence machines going on murderous rampages.
So not just programming, but some kind of deeper interaction.
Potentially.
Huh?
The idea that our thoughts, our very consciousness, could influence these advanced systems in ways we don't yet fully comprehend. It's truly mind-boggling when you really stop and think about it. Wow, what an incredible journey we've just had. Delving into the fundamental nature of energy, the mind-bending observer effect, and the deep interconnectedness of quantum entanglement, and then connecting all of that to the profound implications for human consciousness and the future of AI. It's a lot to take in.
It really is. And it's clear how these scientific advancements are, just as our sources suggest. They're not only expanding our understanding of the universe in unbelievable ways, but they also seem to be bringing us back full circle almost to profound spiritual knowledge, a deeper awareness of interconnectedness. The lines between the material and the spiritual truly seem to blur a little more with each new quantum discovery. It shows us a universe that's far more unified, far more entangled than we previously conceived.
Yeah, unified feels like the right word. And so we leave you with this final provocative thought, building on everything we've explored today. Given the scientific evidence, or at least strong suggestions, that your thoughts are a form of energy that can interact with and influence particles, and considering the truly vast implications of this for advanced AI and maybe for the very fabric of reality around us, what does this mean for your personal responsibility? What does it mean for your potential impact, conscious or maybe even unconscious, on the world you inhabit? Something to really mull over.